Hello and welcome. Let's do a question on for straight maths. This question appears, or rather will appear, I think it's on my synoptic paper Y, and I thought I'll do a little video because I keep doing a lot of advanced stuff most of the time. Nevertheless, it's quite a hardish question the way I present it. It's a 4.5 star, and what the question is saying is to find the minimum value of f of x, where f of x is 1 over 30 sine x cos x minus 16 cos squared x, so long as the x lies between 0 and pi over 2. So where do we start with something like that? Minimum says kind of like calculus. Will calculus work? Yes. Is it going to be pleasant? Probably not. I wouldn't even consider that. So I will consider probably, before I go into calculus, some kind of manipulations, trigonometric manipulations, because I'm seeing here on the denominator some quantities that ring bells. So let's have a look what we could do here. Sine x cos x with a 2 at the front is something that we should all recognize. So that's 15. I'm going to put all the steps in. Sine x cos x, so that's this bit here. And minus this on the next line, just so you can see where I'm heading and why I'm going to do what I'm going to do, is of course 15 sine of 2x. Now I cannot really have arguments of 2x and x in there. It's a mess. So I have to somehow think, how can I change the cos squared into something that has 2x? Of course, further mathematicians, particularly those who have done, we're doing a lot of polar coordinates, you should know cos squared x. And even straight mathematicians, those who decide it's come a lot in integration, and they're kind of symmetrical. One has plus, oops, and one has minus. The minus the one with the sign. So they look like this. And there's nothing but rearrangements of the cos double angle. So I'll show you this one because this is the one we need, in fact. So let's have a look what we can do in there. So if you look at your cos of 2 theta, I'm going to use theta for the identity, is of course 2 cos squared theta minus 1. Standard double angle identity. Now, if we rearrange it, 1 plus the cos of 2 theta is of course 2 cos squared theta. And because I've got enough of those in there, what I might do there, so I have it ready, is I might multiply both sides by -8. So I'm going to say minus 16 cos squared theta is equal to -8 minus 8 cos of 2 theta. So if you look at what I've got in there, I got in theta there, I got in x in there. This quantity is in fact minus, actually not minus because the minus has been taken. I use the minus, a little bit tricky there to actually see. I hope you can all follow. I did use the minus to actually write it like that, so it should be plus in this particular case, or it should be the minus. Wait a second. Maybe we should be very careful. I can see that is in fact a minus now, but probably for everybody to see, this is definitely that. So I'm going to actually proceed. This is the minus as I'm seeing it in there. And 16 cos squared theta, I'm going to use a bracket. And I'm going to say this is definitely 8. It's very easy to make mistakes. I make mistakes all the time with stupid things like that if you're not careful and you're rushing. Pardon me. So I'm going to rewrite it as 15 sine of 2x, not theta there. It should be x. The function is a function of x. So minus 8 cos of 2x minus 8. So this is as far as I've taken so far. And now the question is, now what from this particular line? Let's clear and make some space. And let's look at this particular quantity. There's two things I need to consider. How will I minimize that? It's a fraction with a fixed numerator at 1. Let's put it somewhere in the center. So to make it as small as possible, I need to make this denominator as large as possible. For that -8, I've got no control. Have I got some control for that? The answer is yes, I can. This is, in fact, what I call an R transformation, and for obvious reasons, because we normally use an R transformation on, okay, in speech marks. So we can write this quantity as r sine of 2x plus some phase angle alpha, where r is of course positive number, and this alpha will be an acute angle. Or we can write it as a cos. Here, to writing as a cos is going to be a bit of a pain. You have to be very careful. I have to factorize a minus. But if you allow me, I'm going to kind of fudge it, and hopefully nobody see what the problem might be with this. So we can write it as r cos 2x plus beta, different phase angle now. But the r, of course, is identical for both of those. And the r is Pythagoras of those two numbers at the front. So it's going to be 15 squared, which is 225, plus 8 squared, or negative 8 if you prefer it, 64. So this is going to be the square root of 289, which is of course 17. So it doesn't really matter whether you write it as a sine or as a cos. You can do either. The r at the front is 17. The angle, the phase angle, we don't really care, or this quantity here. So what I'm going to do, I'm going to write this as 17 sine of 2x plus alpha. This is by r transforming this quantity here minus the 8 with a 1 at the front. And now we can wonder what will happen in there. The sign of any argument will oscillate between -1 and 1. So this will take two extremes. One extreme is, of course, actually, let me not write because it will confuse things. So this quantity will oscillate between -17 and 17. What are we trying to do? We did mention earlier on, we're trying to, in order to make the whole fraction a minimum, we need to make the denominator as large as possible. And we won't do that by putting a negative 17. We'll do that by putting a plus 17 minus 8, which of course, this will give us the value of 1/9. Okay, in fact, the question, looking at it now on my paper, it does say, show that the minimum value of f is 1/9. Sorry, I did go a little bit quick on this particular question, but I hope you followed it. I'm a little bit out of practice with my explanations, particularly at lower level. I haven't been teaching now for a good 6-7 months, and you will forgive me for that. But I hope you all made sense, and I'll be signing out, and I'll see you real soon. Bye for now.